To begin with basic static analysis, we will first load the malware into PE Studio, which shows us the modification time and the indication that the malware is not a portable executable. However, since this is not much info, we will move on to virus total scanning, in which in the detection page we can see that the malware is a ransomware and a Trojan, and the virus total even shows us its name, which is WannaCry. Moving on to the details page, we get to see its basic properties, its history, and its names. And from basic property, you can see its MD5 hash, which we will keep in mind for now. And then in graph summary, you can see this, which is the virus total relations. And then we'll move on to PEID, which shows us that the malware is not obfuscated and is not packed, as we can see its programming language here. From here we put in the malware into WinMD5, which shows us its MD5 hash. And as we compare it to the virus total ones, we see that it's the same, which tells us that the malware that we're analyzing is the same one as the one in virus total. So its information is correct. And we move on to PE view, which shows us the administrative information. We can see that the malware was compiled in 2010, and from the import table you can see some functions and DLLs that it imports. However, we will not be going deeper into it there. We now come to dependency walker, where you can see that the malware imports 7 DLLs. So kernel DLL, you can see that it imports functions like create file and read file, which tells us that the malware may be using it to read contents of files to encrypt them and hold them hostage for ransom, tying back to its role as a ransomware. Then we can see in NTDLL that it uses NT-based APIs, which give the chance to the malware to stay under the radar. In advanced API .32, we get to see that it imports functions like crypt gen random and crypt acquire context A, which may be used by the malware to encrypt the files for its ransomware purposes. We then see under ws2._32.dll that it doesn't import much function on its own, so we'll move on to the DLLs imported by it. So in ws2 help.dll, we see that imports functions like var create socket handler and var close socket handler, which helps the malware to propagate around the network as it handles the sockets that it communicates through. Then we move on to msvc p60.dll, which on its own also doesn't import much relevant information. So we move on to another DLL under it. So from here we can see that one of the notable functions imported by the DLLs imported by the first DLL is get system time as file, which indicates that the malware may be using it for time-based operations or to timestamp its activities. Moving on to IPHLP API.dll, it imports functions like get adapters info and get per adapter info, which may help it in enumerating the network and collect information such as available adapters and IP addresses, which enables the malware to spot potential targets for further propagation within the network. Then we move on to wininet.dll, which imports functions such as internet close handle, internet open A, and internet open URL A, which works together to conduct a string of internet related actions like opening a specific URL for reading. So this means that the malware may be contacting a URL via the internet to get further instructions or to gather resources. Under wininet.dll, there's another DLL called shlwapi.dll, which contains URL related functions such as URL canonicalize A, URL combine A, and URL unescape A. So these functions deal with the manipulation of URLs, which suggests that the malware has already encoded a URL it is using while attempting to get into a system to avoid detection. But once it makes its way in, it will decode its encoded URL and piece it together to connect it. And then we move on to another DLL, which is this, which uses functions such as sprintf copy and strns copy and free, which are used to format strings and copy a specific number of characters and freeing memory. So this implies that the malware was using functions to get to files and directories with the data, copy it, then release the used memory after doing so to clean its traces. We then move on to string analysis by using bin tags. So as you can see, the malware uses internet open A and internet close handle, which suggests that the malware may be using the internet to connect to an external link. And here we see some directory stuff, and then we see this executable as well. So this all suggests that the malware may be executing the executable file, which means that the main payload is inside it. And then we see functions like file create A and file create process A. So this in total suggests that the malware may be creating new files and processes within the infected devices, meaning that we should be on the lookout for it when proceeding with dynamic analysis. And then we see a URL here, which suggests that it does connect to an external URL. And then here we get to see some strings that may be connected to each other, like TW and NRY and WannaCry at 2017. Then we move on to advanced static analysis with IDA Pro. So from here we can see that the malware uses a typical if construct, and then moving on we can see that the link appears as well, which confirms that it will connect to the external link. So once the malware is unable to connect to the internet from here, this subroutine is here. So from here we can see open SC manager, which suggests that the malware connects to a service control manager on a specific computer and opens a database to retrieve this executable. So this is likely used to exploit a vulnerability in the machine. We then go deeper into this log here, and we see the assembly language of the code. And then we can see that the malware proceeds to register the service, and upon successful registration, the service is started and it calls the subroutine this. So once we go in and dig even further through this subroutine, we see that there is crypt acquire context A, which is used by the malware to acquire a cryptographic context to perform its encryption and decryption operations. Then moving further down this branch, we see this part of the code where we can see crypt gen random, which the function generates random numbers, and when used in the malware, it might be used to generate cryptographic keys to encrypt the victim's files. Then moving down the code, we get to see this with create process A, create file A, write file, and close handle. So this suggests that the malware is preparing itself to perform functions with the retrieve function addresses. Then we moving further into the code, we see all this. We see like the directories again, which but it comes with this, which tells us that it renames an existing file with this directory and creates a new file with this directory. So it tells us that this file is in this directory. And from this, we can tell that the malware creates an executable file in which the main payload is created, stored in a dynamically constructed file path, so that it is able to target specific files or directories in the infected system. So that is the end of static analysis.